Good day, everyone. We are here again. Welcome to Chem Classroom with Auntie Taiwo. So today we'll be doing another question under acid-base titration. You know, the question comes in different ways. And today we'll be doing a typical question that involves water of crystallization. So we'll be asked to calculate the number of moles of the water of crystallization and the percentage by mass of the water of crystallization. So let's go to the board and see what we have to do today. If you have not subscribed, kindly click on the subscription button, share with your friends, view, like, and comment. Yes, comment how Chem Classroom have been helping you in your exams. All right, let's see what we have on the board. Okay, so we have a acid-base titration which says 25 cm cube of 3 grams of hydrated sodium triiosocarbonate. 4 solution, that's your Na2CO3. Then we have water. Anytime you hear hydrated, water should come to your mind, of course. Part 250 cm cube was neutralized by what? By 13.20 cm cube of 0.16 mol per dm cube HCl solution. So the first thing we are asked to do here is to what? So we are going to start solving right away. Solution, we have to write the equation of the reaction. So for the equation, we have what? Na2CO3. Of course, the number of water of crystallization we don't know, is reacting with what? HCl solution. Now our salt will be formed, our NaCl will be formed, plus what? X plus H2O, because X plus 1 H2O, we don't know the number of water of crystallization, then plus CO2. So let's see if it's balanced. It's not yet balanced, so I'll put 2 here, then I'll put 2 here. So I guess is balanced. Okay, so the next question is to look for what? The concentration of the base in mole per dm cube. So we are going to use our CAVA equals to CBVB, CAVA over CBVB equals to Na over what? NB. So let's write out our parameters before we go. So our Na equals what? Our Na is 2, our NB is 1, our CB is what we are looking for. Our CA is there in the question, is 0.16 mole per dm cube. Then our VA is what? What's the volume of our acid was neutralized by 13.20. Then our VB, volume of our base, is what? 25 cm cube. Right away, so I can now substitute these values into my, so CAVA over CBVB equals to what? Na over what? NB. Okay, so I'll make my CB the subject of the formula. CB is going to be what? CAVA NB divided by what? VB NA. So we can go ahead and substitute the values that we have here. So my CA is 0.16 multiplied by my VA is what? 13.20. My NB is what? 1 divided by what? The volume of my acid is 20, of my base is 25, multiplied by what? The Na, which is what? 2. So in all, here we are expected to have what? 0.0422 mole per dm cube. Okay, it's very, very important for you to write out your parameters the way I just did, so that you don't get confused along the line. So the next question says we should look for what? The molar mass of the base. Now the first thing we have to do is to convert. They gave us what? 3 grams of the Na2CO3 hydrated per 250 cm cube. So there is a little conversion that we are expected to do in this kind of question. So I will say we're given what? How many grams? 3 grams in 250 cm cube. So I can now say X in 1000 cm cube. I have to convert to grams per dm cube. So I will have X equals to what? 3 times 1000 divided by 250 will give me what? 12 grams per dm cube. Yes, 12 grams per dm cube. So from here now, I can proceed and use this formula that says concentration in mole per dm cube equals to concentration in grams per dm cube over molar mass. So then I will make molar mass the subject of my formula. So my molar mass is going to be what? My molar mass is expected to be concentration in grams per dm cube divided by concentration in mole per dm cube. Yes. Okay, that's being done. So my concentration in grams per dm cube, of course, is 12, divided by my concentration in mole per dm cube, which is 0.04220. So in all here, for the molar mass, we are expected to have 284 gram per mole. Yes, 284 gram per mole. And one thing about titration question is this: once you miss question number 1, you won't have a good result, because whatever you get in question 1, you are likely to use it in question 2 and question 3. It just proceeds like that. So we have been able to calculate for 2. So now let's go to 3. Yes, we are gradually moving. Okay, we have calculated. Okay, we are on the 4th question now. The value of what? The value of x. Now this is what we'll do. This is our base. So I have Na2, CO3, okay, Na2CO3, and I have the X, H2O. So we have done the molar mass. Everything here is 284. So if you calculate the molar mass of Na2CO3, is going to give us 106. Yes, you can confirm that. Plus, now the molar mass of water is what? 18. So I'm going to have plus 18x equals to 284. It's just a simple mathematics that we are trying to do here. So I'm going to have 18x equals to 284 minus 106. So here 18x is expected to give us what? 178. Then my x will now be 178 divided by 18, and is expected to give me what? To give me 9.89. So I can approximate that, of course, to 10. Yes, we are almost rounding up now. So for the last question, the percentage by mass of the water of crystallization. Okay. Now coming to the percentage by mass of the water of crystallization, my x is what? My x here is, although I approximated, but for the purpose of the solution, I will still use the 9.89 multiplied by what? Water, which is 18, divided by the molar mass, which is what? 284, multiplied by 100. So in all, you are expected to have what? 62.7%. So we have been able to solve this beautiful question. And this is under volumetric analysis. And you know that you will do volumetric analysis, which is your quantitative analysis, and the qualitative analysis. Okay, in our next class, we'll be going to the qualitative analysis. I will show you the cations, the anions, and how you can actually test for them. Okay, so please tell your friends that Auntie Taiwo is teaching the nucleus of existence on Chem Classroom. See you some other time. God bless you.